Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss topic regarding axial flow reaction turbine, under which we'll discuss about Kaplan turbine. So here in the axial flow reaction turbine, two terms we can identify. One is axial flow, another one is reaction turbine. So axial flow turbine or reaction turbine actually. Now here it is axial flow reaction turbine. So actually, when we have discussed the turbine classifications, there I told you that turbines are basically two types as per the energy. One is impulse, another one is reaction turbine. Again, in impulse, we have discussed about the Pelton turbine, and in the reaction turbine, we have two types. Like one is Francis, another one is Kaplan is there. Even many types are there, but basically we used to follow only Francis and Kaplan. So we'll discuss here Kaplan turbine under axial flow reaction turbine. So first of all, try to understand what is axial flow turbine. Axial flow turbine. So axial flow turbine actually when water will flows parallel to the axis of the rotation of the shaft. So the water will flow. How the direction will be? Water will flow parallel to the axis of the rotation of shaft. Axis of rotation of shaft. Then it is called axial flow turbine. And when it can called reaction turbine, so we have seen previously also, the reaction turbine is nothing but at the inlet of the turbine, the energy should be, or we can say the total energy should be like it is the sum of pressure energy as well as kinetic energy. And during the flow of water, then flow of water in the runner, the pressure energy will be partially will be converted to kinetic energy. So that is known as reaction turbine. So that already we have discussed previously. So here the axial flow reaction turbine is nothing but here the turbine shaft of the turbine will be vertical here. Now you can see this is the actually diagram of Kaplan turbine. Okay, before going to this Kaplan, let me tell you that this axial turbine actually it is of two types are there. One is propeller turbine. One is propeller turbine. Another one is Kaplan turbine. A small difference between this propeller turbine and Kaplan turbine is in the propeller turbine, the blades are not adjustable, that is fixed. The blades or vanes we can say, here we can see these are the vanes. Okay, so these vanes are fixed. It cannot be movable or it cannot be adjustable. But here in the Kaplan turbine, vanes are adjustable. That is the only difference between these two turbines basically. So which kind of vanes I'm talking? The vanes which is attached in the hub or boss. So what is this boss and hub? That also I'll tell you. So these are the two types of axial flow reaction turbines are there. Now here we'll discuss about the Kaplan turbine. So Kaplan turbine actually initially it was invented by V. Kaplan. The name of the scientist is V. Kaplan. Based on his name, this turbine was named, and he is an Austrian engineer. So he developed this one. So the diagram what is shown here, it is actually the Kaplan turbine only. So here some components are there. The main parts of the Kaplan turbine we can say, or some components are there which we will discuss in this working principle. So first one I can consider the scroll casing. This one is the scroll casing. So first we can write only casing, or you can mention, or we can mention specifically scroll casing because it is used in this turbine. Second one is nothing but the guide vane mechanism. Here you can see this is the guide vane is here. Both the sides we have the guide vanes are there. So the next one we can write the guide vane mechanism. So third one is nothing but the hub. This is the hub part which is situated along with the shaft. It is connected, and in the hub, or it is called boss also, hub or boss. In this the vanes are attached. So here actually hub with vanes you can say hub with vents. So this will work as a runner of the turbine, or we can say here it is for this Kaplan turbine, this will work as a runner of the turbine. So the hub and boss is taken separately here, we can see. So as I told you, the shaft is here, this one the shaft, and the number of vents are fixed on this. Like we can change it, like we can adjust this vane angles and directions. So that is there. And the last one is nothing but this is draft tube, hub and boss, scroll casing, and this is guide vane mechanism. And the last one is nothing but draft tube. So these are the components or parts are used in the Kaplan turbine. What are the how these components will be involved in the working of Kaplan turbine? Now we'll discuss. So as I told you that here, if you see, this is the top view, we can say, of this turbine. So this is our entry part of water or fluid which is coming here. So this is nothing but the scroll casing, as it mentioned here. So the water will be come out from the dam through a penstock. We know that penstock is nothing but a long pipe which is connected from the dam to turbine. So here, when the water goes inside, it will be goes through this with the help of this scroll casing. It will goes inside the turbine here. Now, this is the movement of, you can say, this water will be moved here. Now you can see the water is coming here inside through this direction, and after crossing the guide vents, here you can see the guide vents are there. These are the guide vents. You can see here the number of guide vents are there which are fixed. Okay, these are fixed actually. We cannot change it. This is fixed. So through these, the water is started moving to goes inside here like this. It will go inside here. Once it goes inside, it is going to strike, like you can see the direction here. As I shown you here, again you can see in this point, the water comes through the guide vents and it goes inside. And after coming inside, it is going to strike the vane which is available at the boss or hub. That is going to strike at the vane. Then the vane started rotating. Once it started rotating, the hub also started rotating, and the hub is connected to the shaft. So the shaft also started rotating, and the shaft is connected to the generator. So in this generator point, we can produce the electricity. So this is a procedure. So as I told you that it is going to strike this vane, and which is connected to this hub, and it started rotating. So the direction you can see, it is parallel. Now the direction of this water is parallel along the axial axis of the shaft. As I told you, the water flows parallel to the axis of rotation of shaft. When the axis, this shaft started rotating, so axis point of this shaft will be like this. What are the direction of this fluid? This is also same. So all are parallel to each other. That's why it is called axial flow reaction turbine. So reaction turbine, we know that, as I told you, that kinetic energy and pressure energy both will be there when it is coming inside and it is going to strike at this point. Both energy will be there. After striking the vane, okay, the pressure energy is converted to kinetic energy, so that the pressure will be low here. So during the strike, your pressure started reducing and velocity started increasing here. So after striking here, this working over, finally the water started moving out here from this outlet of the runner to tail race. So tail race is here. You can see tail race at this point, or you can say some bottom point of this. So there is a draft tube is attached at the outlet of the runner to the tail race, so that the exhaust of this water will come out from this runner and it will goes to the tail race. So here it will be useful, or it will be helpful for the water when this pressure of the water is equal to or is more than the pressure at the liquid which is present in the atmosphere. But as I told you, during the fluid movement or working of this vane, this one, when it is striking on the runner, due to the shape of this vane, we can say there will be a pressure difference in between, like before striking and after striking, we can say. So after that, your pressure reduced here, then we'll get a vacuum pressure will be there in this at this point. but velocity increased. So that we have attached a draft tube at the end of the runner. So the draft tube, what will happen? You can see it is in increase in area. The draft tube is increasing area, and different shapes of draft tubes are there. So by increasing of this area of draft tube, here area increase means you can see our velocity will be decreased, and your pressure also started increasing. So by this we can improve the pressure, which is already in the low. Now it started improving. That means the pressure started increasing here. So that will be equal to, or it will be more than the pressure which is present at the atmosphere. So that easily the water can come out from the turbine to the tail race. So this is the use of draft tube, okay, and use of scroll casing, as I told you, and the guide vanes mechanism is nothing but here two guide vanes will be there, and the water which will come out from this outside through the penstock to here, so that water will be goes inside through the guide vanes. So guide vanes will be fixed, and it will give the direction to the water to goes inside. And hub with vanes is nothing but, as I told you, this is the hub part actually, or hub or a boss. It is called boss. So these are the number of vanes. You can see this is one vane, this is one vane, this is one vane. So like that, vanes are attached in this hub, and in this hub, the shaft is attached. This one you can see shaft. As I told you, the shaft will be connected to the generator to produce the electricity. So this is all about the working principle of this Kaplan turbine. Now, when the discharge of this Kaplan turbine will be calculated, we need to evaluate, like we need to find out the area of this, area of the, you can say runner. That means discharge of water from the turbine, we know that Q equal to AV. Okay. So in here area you need to calculate in different way, like we know that pi by 4 d square will be for different, but here we have two diameters are there. So the things we need to consider here, pi by 4, here is do square, another one is d, you can say h or b, anything we can mark it actually. So h is diameter of hub or diameter of boss. As I told you, hub or boss, both are included. This minus this into this velocity will be considered as the VF1, the flow velocity. So by this we can calculate the discharge of the water. So here DO is nothing but outer diameter of the runner. DO is nothing but, you can say, outer diameter of runner, and dB is dB or dH. I told you that both can be taken, dB or dH. This is diameter of, you can say, hub or we can say boss, anything whichever we have mentioned. Now similarly, VF1 is nothing but, this is velocity of flow at inlet condition, velocity of flow at inlet condition. So these are the terminologies are there to use the discharge of the fluid, and some applications are there for this Kaplan turbine. So this can be used in different areas. I'll just give a few example of this. Yeah, some advantages and disadvantages also there. I'll just give a brief idea about the applications. So applications can be done for this Kaplan turbine in different area, like specifically if I say, it can be used for low head. It can be used for low head and high discharge. When you require high discharge and low head conditions, we can use this turbine. So this can be also used as the advantages also. And along with that, this can be used for the hydroelectric power plant. Hydroelectric power plant. And along with this also, I can say this can be used for the tidal hydroelectric power plant or tidal power plant also. Next, this can be also used for like dam outlets. Dam outlets purpose for the electricity produced. Even we can use this in the irrigations also. So these are the some applications of this Kaplan turbine, and along with that also we can use this. Sometimes you can use this in the like gas turbine. The gas turbine is nothing but we can say like jet engine. Okay, so these are a few examples are there of Kaplan turbine, and along with this I'll tell you some advantages and disadvantages. Advantages, disadvantages is quite simple to write if you understand the concept here. So as I told you, the first point what I have written here, that is it can be used for the low head and high discharge for the power plants. Similarly here also we can mention, yeah, so the first point we can mention this can be suitable for low head. Same thing again. This can be suitable for low head. Just we can change some wordings so it will be easy. And your discharge is more here in this point. Similarly, this also can be written like efficiency is high. Efficiency of the turbine is high for some partial load, and it requires some less space. We can say require less space area, and also we can say this is a smooth operation is there for to conduct the to run the turbine, smooth operation. And as I told you that discharge is high, so here our specific speed also will be high here for this point. Specific speed is high. So these are the some advantages of this turbine. Along with that also we can write some disadvantages. So again these disadvantages also we can identify from the advantages point, like what is advantages is there. First one is there low head. So what I can write here, this is not suitable. This is not suitable for high head condition. So this is one disadvantage we can say, and this is not suitable for the low low discharge case. That also we can write. And some disadvantages we can write like cost effects are there. So initial we can say initial cost of investment is more, and similarly we can write some maintenance cost also. When we are talking about the initial cost, maintenance cost also we can say a little bit higher. Along with that we can say, as I told you, not suitable for the high speed. And yeah, now here if you see the hub part, this part will be very heavy actually. Along with this, when you are fitting these blades, so it is very concise or precise manufacturing of blades are required. You can say that precise manufacturing of blades and guide vanes are required. Manufacturing of blades are required. It is not disadvantages, but it is sometimes required to better efficiency. So because it is slightly difficult, that's why I'm writing in the disadvantages. And the cavitation formation will be there. So to avoid the cavitations, we need to always keep on pressure, like how to manage the pressure. That is one big task. So there will be some pressure risk will be, or cavitation risk will be there in this turbine also. So these are the some, like as I told you, disadvantages and advantages of this turbine, and these are some applications are there. And as I told you the working principle of this, I hope you understand. These are the basic parameters or basic component of the Kaplan turbine. So still, if you are having any kind of confusion and doubt regarding this Kaplan turbine, you can give a comment on the comment box. It's very simple. Only we need to understand that how the flow is going inside the turbine. Basically, if you see when it is coming from outside, it will be goes through like tangential direction. Slightly, if you see, it is goes inside this one tangential direction. But here, if you see, it's not looking like this similarly, because here it is given like guide vanes are there. It is in this mode. So we can change the guide vanes directions slightly, so that the water will be goes and it will be goes inside like tangentially. And after going here, it will be like it will be goes down to this one. So that is the axial flow. So that will be axial flow. That's why when it's entered in the inlet condition, it is slightly tangential direction will be there. But when it is entered inside this one, we'll get axial flow. So that's why it is parallel to the axis of the rotation of shaft. That's why I told the first one. This is the one important one. And the discharge part we have seen here, Q equal to AB, this value. And here if you see DO and DB, that is nothing but diameter of the runner and diameter of the hub. So diameter of runner is nothing but, here if you see, runner vanes is there. So which is the runner? This is the runner part, correct? So runner is nothing but, as I told you, here the hub with vanes will be act as the runner. Okay, so what is the diameter of this runner? This up from here to here, that is the runner blade is there. So diameter of this is runner, diameter of the runner. Now where is the boss is there? This is the, I'll give a different color. Suppose here you can see this is boss or hub. So what is the diameter of this? That will be considered DB, and diameter of this runner will be, that is DO, that is outside. So it is more. So DO minus DO square minus DB square into velocity of flow, VF1. And these are the some application advantages and disadvantages. So I hope you understand. Still, if you are having any kind of confusion, doubt in this, you can give a comment on the comment box. Thank you all.